Hello everyone, welcome to Code Scam, and today we are going to cover the next part of how Quicksort works and the problems solved using Quicksort. In our previous video we saw what is a Quicksort and how does it work, what is a pivot, what is the worst and best time complexity of Quicksort, and how divide and conquer works in Quicksort. So now it's time to apply the logic in some problems and see how we are going to solve them using the logic of Quicksort. So let's start with easier ones first in the video. The first problem we're going to see is sort binary array. Simple. The input given is a binary array consisting of zeros and ones, and we have to sort them first zeros followed by ones. So we can do this in a sort just by using any sorting algorithm, but how do we do it in linear time and in place? So the logic we're going to use is quick sort. So first, as we saw how Quicksort works in detail in our previous video, if you're not familiar with the logic, please go and check the video. I have given the link in description. And now using the same logic as we saw in our previous video, we are going to have a pointer I and j starting at our first index, and we're going to set our pivot element as 1 because we know in one pass our pivot element will be placed at exactly where it has to be. The numbers less than pivot element will be at the left side of the pivot and greater than pivot element will be to the right side of the pivot. So now our pivot element is 1. So automatically after one pass of partition algorithm, all zeros, that is the number less than 1, are going to be in the left side. In that way, in one pass, it is going to sort the given array. So now let's start having our I and j at first index. If you check whether it is less than our pivot, that is less than 1, yes. In this case, it swap I and j. Since I and j are in the same position, even though the swap happens, 0 stays in the same position. So now moving our j to the next element, our I stays there because we know our I remembers where the numbers less than pivot exist. J is to scan the array. So now J is scanning the array. It is checking whether 1 is less than 1. No, it is not less than 1. Again, we are moving J to next. It is again 1. It is not less than 1. So we are going to move to 0. So now in this case, 0 is less than our pivot element. That is less than 1. In this case, what we will do, we will switch the value with where I is. So according to our algorithm, once we are done traversing our I, we swap one element. Once swapping is done, we move I, that is we iterate I to the second position. Now our I is at this position, our j is this position. We are going to swap 1 and 0. So now our 1 and 0 are swapped. Once swapping is done, it's time to move our I. So our I is here and j is here. So now j checks whether it is less than 1 or not. No, it is not less than 1. So time to move j. So it is checking whether 0 is less than 1. Yes, it is less than 1. So it's time to swap I and j. So once you swap, it becomes this. That is 0 and 1 is swapped. Once swapping is done, it's time to move our pointer I to the next position. So now our I is here and j is here. So swapping is done. So j moves to this one. It is again not less than 1. So again j moves to 0. So 0 is less than 1. So it's time to swap I and j. After swapping, it becomes like this. So if you see, the array is already sorted. All zeros came in front and all ones came in back just in our fifth iteration or fifth pass. So in one pass and using constant space, the array is already sorted so quickly. So the code looks something like this. This is very similar code to what we saw quicksort partition. We have a pivot, but instead of picking an element from the array, we decided to set a pivot as 1, and we start from I equal to -1. So we iterate j through the array, and whenever we check array of j is less than 1, we iterate I and swapping happens. So in one pass, the algorithm sorted the array. So this is the simplest easier program that where we can apply our quicksort logic. So moving on to our next program, that is arrange negative and positive numbers. If you see, we have given an array of negative and positive numbers, and we have to arrange all the negative numbers first, again with the positive numbers. But these numbers are not in ascending order or not in sorted order. But we have to assemble every negative element to the left side and put all the positive elements to the right side. So if you see this, you can normally use any sorting algorithm to sort this. Again, I want to sort this in minimum time and constant space. To do that, we're going to apply the same logic we used in the previous problem, but instead of using 1 as a pivot element, I'm going to set pivot is equal to 0. Why? Because as we know, after one pass, the elements less than pivot going to be at the left side, and elements greater than pivot is going to be at the right side. So as we set pivot is equal to 0, so the negative numbers will be less than 0, so they will be assigned to the left side, and the positive numbers will be greater than 0. So choosing the pivot element is very important here. So now start our iteration by keeping I and j here. It checks whether it is less than 0 or greater than 0. Our algorithm is going to check if it is less than 0, then switch. If it is greater than 0, then move to next element to scan. Here 12 is greater than 0, so our j moves to 11. So again it is greater than 0, so j moves to minus 13. So minus 13 is less than 0. In this case, we're going to switch 13 and 12. That is the element at array of j and the element at array of I. So now the array becomes this. That is 13 will come to the first position and 12 come to the third position. So now it's time to iterate our I. Whenever we do swap, we iterate I. So our I comes here and j goes to minus 5. In this case, minus 5 is again less than 0. So it's time to swap I and j. So once we swap, I comes to, that is minus 5 comes to second position and 11 goes to the fourth position. Once swapping is done, it's time to iterate I. So our I goes to 12 and j goes to 6. 6 is greater than 0, so j scans the next element, which is minus 7. So now minus 7 is less than 0, so it's time to swap 12 and minus 11. So now 12 and minus 7 swapped. Now time to move our I here and j to the 5. So 5 is greater than 0, so j switches to minus 3. So minus 3 is less than 0. In this case, we have to swap minus 3 and 11. So minus 3 and 11 swapped. Once swapping is done, iterate I. So I goes to 6 and j points at minus 6. So minus 6 is less than 0. In this case, swap I and j and done. So in one pass, we have sorted all negative numbers to the front and all positive numbers to the right side. So it is again the same code we're gonna use, but instead of setting the pivot is equal to 1, we are setting pivot is equal to 0. Otherwise, the code is going to be the same, the logic is going to be the same. So yes, we now came across two easier problems. So moving on to our next problem, that is arrange negative and positive numbers alternatively, which means we are given an input of integer array with positive and negative integers. We have to return the output as one negative and one positive. Again, one negative and one positive alternatively. So how do we do it? If we have to sort them negative and positive group together, we can use sorting. How do we do it? If you think of a logic, quicksort comes to help to make it really quick. So now we know in our previous problem how to set our values or group our values, that is negative values together and positive values together. We're going to have the same code, same logic to separate them first into negative values and positive values together. So now we're going to have pointers, that is usual logic we use, the fast and slow pointer. For example, having a negative pointer at the first position and having a positive pointer here where our positive numbers is there. How do we find it? If you see our previous algorithm, when you stop sorting the array, our pointer I will be placed exactly at the pivot position. So same way, by using the final position of I, we're gonna find where our positive numbers start. So by pointing at the positive number, our positive pointer is going to be there. So let's consider our positive pointer is going to be the slower one and negative pointer is going to be the faster one. That is, negative pointer moves two steps at a time. Positive pointer moves one step at a time. So whenever it moves, it's gonna swap the values. So now it is at 13 and positive pointer at 12. We're gonna swap 13 and 12. So we have swapped 12 and minus 13. So now our positive pointer moves once and negative pointer moves twice. So negative points at minus 7, positive point at 11. So it's time to swap. So once that is swapped, again it is going to move faster and positive is going to move slower. So every time it moves faster and slower, it's going to swap and finally arrive at a solution that is one value positive and one value negative. So our code looks something like this. That is, after using partition algorithm, our I plus 1 is going to point at next position to pivot. That is, it is going to point at the starting value of positive integers and negative integers start at 0. So iterating through it, every time the positive pointer moves once and negative pointer moves twice, and swap happens between the positive and negative. So it is very pretty simple algorithm. So now in this video we have covered three simple problems where we can apply quicksort's logic to perform sorting in lesser time using constant space. Let's move to quite advanced problem in our next video, so keep looking. If you like the video, hit like and subscribe. We'll explain or and go through a lot of problems in upcoming videos in the same series. So thanks for watching. Thank you.